Assalamu alaikum wa rahmatullahi wa barakatuh. Well, it's final lecture of the System Analysis and Design course, lecture 2 of chapter 14. Well, what we are going to cover here is the rest of the maintaining information system. In other words, the maintenance. What we are going to cover in this lecture is the following. First of all, managing maintenance personnel. How are we going to manage the personnel? Are we going to have them a separate group or combined, etc.? And we'll see how. Measuring the maintenance effectiveness. We have to find out, how, effective our choice of managing the personnel and how really we maintain our system. So we could have really some statistic, how many problems we have, is it decreasing, is it increasing, etc. Then control maintenance request. How really we control the maintenance request from the customer. And finally, we are going to talk about configuration management. Well, as we said, maintenance, it has really 60 to 80%, even sometimes a little more, of the cost of, the project. 60 to 80% of the budget of the information system department. So we do a lot of maintenance. There's a lot of people working in maintenance. So the number of people working on maintenance has surpassed number working development, new development. And that's what really we said, the people and the maintenance, they are more and more, than the people who are working in a new initiative, a new development. Maintenance work is often viewed negatively by information system personnel. Well, it's a human nature, you like to really write your own program, to start a new program. But you go and maintain an existing program written years ago, sometimes probably decades ago, 20 years ago, and that's what happened to me, when I worked in Detroit Diesel. We used to maintain some programs which is 20, 25 years old. Well, how really organization handle this situation of the maintenance? Since a lot of people, they don't like really to work on maintenance. They like always look at work on new initiative, new development things. So organization often rotate personnel in and out of maintenance roles in order to lessen negative feeling about maintenance people. Organizations have historically rewarded people involved in a new development better than maintenance personnel, which is true, in my work, in Detroit Diesel, usually every time you write a new program or you develop a new subsystem, whatever, you always get, bonus, you get recognition by the people, by management or whatever. But if you work so hard in maintenance, if you work, day and night, and we used to work early days and nights sometimes, and they always look at, it's your job to do. They don't really recognize it. They don't, they don't give you any promotion, and they always consider it as it is really your job to do that one. But when you write a new program, usually you get a bonus, you get appreciation, you get recognition from the people around you. Well, there are 3 different possible organization structure to do that. Right, we try really to do something good for the personnel, but what really we want actually to do something good for the system. So some people, they do it, first of all, in separate groups. Maintenance group consists of different personnel than development groups. You have a group of development, new initiative, and you have a group to just doing the maintenance. Sometimes they're combined. All of us work on, and the problem of that system. If it's a new development, probably you do it if you are available. They give you a new to develop, to write a program. Or, if you aren't available, this means you are working probably in another development or you work in maintenance one. So they combine both groups in one. And sometimes functional, that's the one really I prefer, because functional, you do all the work on that function. Like if you are responsible for registration system at Jordan University of Science and Technology, just so you do everything there. If it needs maintenance, you maintain it. If it needs, a new program to write, a new development, you develop it. And this is the best way, not you as individual, but as a group. The group, 10, 15 people, those, for registration system, other for financial, others, and etc. So if you look at these organization types, each of them, it has advantage and disadvantage. For a separate, the advantage, it's improved system and documentation quality, because it is your job day in and day out. You are specialized in this one, and you are the maintenance group. Disadvantage, ignorance of critical and documented information. Sometimes probably you ignore some documentation or whatever, because it is your job, you have to do it, and probably you don't need really to document it. Combined, maintenance group knows all about the system. The advantage of it. Disadvantage, less emphasis on good documentation, because you don't know, sometimes you do this job, like maintenance, then other time you do probably new development, third time probably you do development, fourth time whatever, so you are not really responsible for the maintenance itself. Functional personnel have vested interest. They have interest in that system, because the system is their own. So they maintain it right, they write it, and actually they develop it right, because they are the one who's gonna maintain it later on. But limited job mobility and human or technical resource. It's probably if you are really specialized in this function, you don't know anything else about the other function. How we measure the maintenance effectiveness? I mean, if we choose one of these types, and in order to find out really if it's working okay with you, probably you keep statistic. You keep a track of what's going on, the number of failures. If we used to have 5 failures a week, and we choose one type of organization, and 2-3 months later, it becomes 10-15 failure a week. This means the effectiveness of that organization, it's not right. So probably you have to change. Time between each failure. Mean time between failure. The time between, the mean time between each failure, a day, a week, etc. And type of failure. Is it really a critical failure? Is it really a massive failure, or a typical one, a small or very, very small one? Mean time between failure, MTBF. The definition of that one, it's really a measure of how reliable a hardware or a software, how reliable a component is. For most components, the measure is typically in thousands or even tens of thousands. Like for 1,000 hours, the system went down for 5 hours or 2 hours or whatever. The measure is typically in 1,000 or 10,000. For example, hard disk drive may have a mean time between failure of 300,000 hours. Like every 300,000 hours, it went down for an hour or 2 or something like that. So anyway, it is a measurement of error occurrence that can be tracked over time to indicate the quality of a system. If you look at this figure 14.7, it shows you the mean time between failure, and this should give you really an indicator, really how the team how effective the team of maintenance is. If you look at it, for this example, month since system was installed, like in month 1, they used to have a failure every couple of days, 2 days or whatever. If you go to month 6, you'll see you have a failure every 21 days. So it is really getting much better with that maintenance team. Well, how are we going to control the maintenance request? Maintenance request can be frequent. It depends on the type of maintenance. There are many different types, as we talked about it in last lecture. Prioritize based on type and urgency of request. Usually, you have probably 10, 15 requests, whatever. So you have to prioritize them. Which one really we're going to do first? Which one we're going to second, etc. And evaluation are based on the feasibility analysis. So we have to do a feasibility study for it to see if it is doable or not, how much the cost, how much really involved, in the change, how many programs we need to change, the cost and the duration. Well, in this case, in this figure, we take the change request and we see what's the type. Is it really corrective? Corrective, right away, it takes priority, so you have to correct it. So really, you don't have to wait really. Others, is it really adaptive, perfective maintenance, or enhancement? If it is enhancement, you evaluate it. Is it needed or not needed? If it is needed, again, you categorize it, you prioritize it, and then it goes, to select the next task in the queue, whatever. And the same for the adaptive or perfective maintenance. Again, if it is, you put it again in the queue and you prioritize it, which one really takes first. But anyway, the corrective one, which is you have to correct, the system, it takes priority on all other type of maintenance. Well, here it shows the maintenance request moves, how it really moves, Change request, it comes from the user. There, they request it. Then it comes there to the project manager, and a project manager send it to the change request team. There is a system board there. They check it, prioritize it, do whatever, and then they come the decision. What is that? Is it like corrective, or it is perfective, or it's preventive, whatever. Then it comes, to the project manager. Either he notify the user or send it to the notify the user of what's going on, and the one we put in the queue sent to the maintenance staff to be done. Well, configuration management. Configuration management in general, CM, configuration management, is a system engineering process for establishing and maintaining consistency of a product's performance, functional and physical attribute with its requirement, design, and operational information throughout the life of the system. Here we're talking about, the process of ensuring that only authorized changes are made to the system. The people who's going to go and pull the program from production library, change it. The change, I think it should be really authorized by a group, by the board we have there, for changing the system. And the only people who are authorized to do the change is the one really who do it. What's a baseline module? Baseline module, software module that have been tested, documented, and approved to be included in the most recently created version of a system. Baseline module is the program or the software module, the program. It's really been tested, documented, and approved to put in the system. Well, actually, we used to have some problems back in the 80s of the last century. When we pull a program from production library, you could really any person who could go and pull the program, change it, and put it back. And there is always a contradiction. There is a conflict between, the people who pull the program. Let's say example, I pull a program to change it, and I work on it for like the change needs to be done. It takes probably 10 days. So you come tomorrow and you pull the program again, you change it in 1 day, and you put it back in production. Everything is working, no problem for a while. After 10 days after I finish my change, then I go and put it in production. So my change is overlay your changes. And this one used to cause really a problem. So what really we did that time, we put a system librarian. System librarian is really a person who is the one who is really in control to check in and check out. You check in you pull the program from the production library. It's under your name, and that the program is locked. Nobody can pull it, from the library again until you finish and you put it back. Then somebody else can do it, and this really solved a lot of problems, and the conflict between, these maintenance effort. A person responsible for controlling the checking out and checking in the baseline module when a system is being developed or maintained. A build routine guidelines that list the instruction to construct an executable system from the baseline source code. You take the source code, the system librarian pull it for you, you give it to you, and the build routine is a guideline how to show the instruction you are going to complete in order to to change the source code and put it back in the production library, which is actually you pull the program and you pull them, of course, the documentation, you change the documentation, you change the program, you test it. After you do a walkthrough, whatever, you do all the test cases, whatever, when you are ready, you put it back again in the production. In other words, you update the library with a new version of the program, and you update the library with a new version of the documentation. Well, how really case tools, rational rows, all these packages, help us in maintenance, and we use them really as an automated tools for that. Traditional system development emphasis on coding and testing. The way they used to be done back in the 60s and the 70s and probably sometimes the 80s, it is really the coding. You pull the program production, you code it, you test it, and you put it back without any change to the documentation. Changes are implemented by coding and testing first. Even if you want to really update the documentation, you update it later on. And sometimes probably you don't have a time actually to go and pull the documentation and update it, because of lack of time, because many different reasons. Documentation is done after maintenance is performed. Keeping documentation current is often neglected due to time-consuming nature of that task. But development with case or rational rows or those one, emphasis on design document. In case tool or rational rows, there is a process there which enforce you to go through the steps in sequential order. So you have to go and update the documentation. You go change the requirement. You add the requirement. You add something, probably you change some models, if there is any model, or then you change probably if that really reflect a change in the design, you change the design. Then you go and you add the program, you change the program, you add something to the database, whatever. Then you test it, and you have to test it thoroughly. You have used all the test cases exist there, and then when everything is okay, then you move on piece by piece, phase by phase, activity by activity, until you install the system. So with the case, emphasis is on the design document. Changes are implemented in design document. Code is regenerated using code generator. Documentation is updating during the maintenance, not after you finish the maintenance of the program. Well, with reverse engineering, we talked about reverse engineering before, in the previous chapters. Reverse engineering, automated tools that read program source code as input and they create graphical and textual representation of design level information, such as program control structure, data structure, logical flow, and data flow. Well, Reverse engineering tool, it is really a good tool for those programs which you don't have any document to them. So you start backward. You take the source code, and then from the source code, the output, it is really the document, which it is, you go back, you represent the design level in a textual, whatever, program control structure, data structure, logical flow, and data flow. Well, engineering, it is different. As a tool here, it is like really you as a programmer. You read the source code and then you change it. You change the logic of it, you test it, whatever, until you go install the new version of that program. Automated tool that read program source code as input, perform an analysis of the program's data and logic, and then automatically or interactively with a system analyst. Automatically and iteratively, alter an existing system in an effort to improve its quality or performance. Well, for a website maintenance, I think there are some special consideration you have to take because the web programs, it's working 24 hours, 7 days a week, 365 days. So there is no good time really to take the system down or whatever, like the other system, which it is usually they work until 5 o'clock, 6 o'clock, when the last employee leave the premises, when they leave the company. I think you could really take the system down, do update, do whatever you want to change to it until next morning. But for the website, I think it should really be up 24/7, 365. And this mean that we have to do it under some guidelines, and the one really we are going to see now. The nature of continuous availability makes maintenance challenging here. Pages under maintenance can be locked. Consider using date and time stamps to indicate when changes are made instead. Well, instead of lock it, whatever, probably first of all, you could really put some notice, whatever, that our website is not going to be available like next Friday from 10 to 10, like from midnight until 6 o'clock in the morning, which is good really to tell the people who's working on that one, because you expect that you have a customer work on this 24 hours. Again, I think you should really check for broken links. I mean, when you do any change to it, or if there is often really you check for any links if it is not connected or whatever to your page. HTML validation pages should be processed by a code validation routine before publication. Re-registration: when content significantly changes, site may need to be re-registered with a search engine. Probably you need to register it. All these consideration, I think it should be taken for the website maintenance. Well, another for future edition, consistency is important to user for the future edition. What really we're gonna do in the future. Post indication of future change to the site. As we said just a few seconds ago, that you put really a note to indicate that we are going to change this so and so, whatever, and the system will be down from 12 to noon to 6, whatever it is, And usually it is really a good practice that you put all your changes at once. Don't try to take your system down every week, every other week, whatever. If it is applicable, if you can do it, probably you could really do it in a batch changes. Put a lot of changes at once, and you take it down for maybe once every 6 months or once a year. Well, finally, we are going to talk about the summary we have tried to summarize the whole chapter, which is the last 2 lectures, this lecture and the lecture before. First of all, we explain, we explain and contrast 4 different types of system maintenance, like corrective, perfective, adaptive, and preventive maintenance. We describe several facts that influence the cost of maintaining an information system and apply these factors to the design maintenance system. And we describe maintenance management issues including alternative organization structure. How we're going to do it, combine, you know, the maintenance structure, you know, the people who's working on that one, or separate, or by functional. Then we talk about the quality measurement, how really we measure the effectiveness of the structure we have, the organization structure really we have. Process for handling change request, how we take the request from the customer, how we prioritize it, and we change it and put it back, you know, in production. And configuration management, which it is, you know, the baseline program, the module, how really we pull it from production library, make sure that only authorized people who really take that system and change it. Finally, we talk about case and how case tools and rational rows tool can really enforce us and enforce really the process of updating or changing or maintaining the system the right way by updating the document, by going through the life cycle step by step, face by face. We change the requirement, then we change the models, then we change the design, then we go change the program and test it and put in production. In other words, we update the documentation while we are maintaining the system. Because usually the traditional way, we used to update the documentation after the fact. After we pull the program, change it, put it back, then we update it, and always, you know, it comes short. أخيرا, this is really the final lecture of system analysis and design, and this is the last lecture. Well, thanks for listening, and good luck to you all in your final, and see you. Bye.